All right, well, welcome everybody to our weekly Wednesday webinar series. Join us actually on May 15th for the ResNet HERS H2O water program, and then April 24th on the ongoing electrification futures study by EIA. And then Wednesday, May 8th is our big Michigan Net Zero Energy Residential Conference located in Grand Rapids. And we'll be scheduling many other events, webinars in between then and after that. Also, if you're tired of registering for every course, want to support our mission, get discounts on paid courses and in-person events like the May 8th event, sign up now to become a member today on our website and get many other benefits. Huge thanks to our sponsors for this session, T-Stud. T-Stud is a 2019 Green Builder Media Sustainability Award winner for structural integrity. So what is the T-Stud? The T-Stud is a game-changing technology. The T-Stud solves the #1 nemesis of construction industry, how to cost-effectively stop the transfer of outdoor climatic heat or cold from affecting the interiors of a structure's ambient room temperature. In plainer terms, it's the best piece of lumber available to minimize the outdoor temperature from coming through all the framing members in a wall to negatively affect the heating or cooling bills. It's a thermally broken insulated wall stud assembly for use in exterior walls and party walls. The T-Stud is an engineered building product that uses 2 lumber members, an internal truss system, and a frothed in place closed cell foam that has a global warming potential of less than 1 and is EPA compliant for 2020. T-Stud provides 99% complete thermal break through the wall assembly. With just one product, the T-Stud raises the bar on 6 major construction concerns: thermal breaks, structural strength, wind loads, sound transmission, fire safety, mold, and termites. The T-Stud isn't complicated. It's easy to replace traditional 2x lumber with the T-Stud, with little to no additional training. Plus, it can be used as studs, jack studs, king studs, sills, cripples, headers, top and bottom plates, and does include rebates as well, potentially. So head over to tstud.com to learn more. All right, well, welcome everybody to Innovation in Frost-Protected Shallow Foundations. This course is approved for 1 hour in continuing education units, GBCI, NARI Green, Certified Green Professional, Certified GreenHome Professional, AIBD, and BPI NonWholeHouse, as well as AIA, Health, Welfare, and Safety, making applicable to your state-based design or contractor license. Today, I'll be your moderator, and my name is Brett Little, and I'm the Executive Director here at the nonprofit, the GreenHome Institute. During this session, we're going to be focusing on innovation in frost-protected shallow foundations that can be used for many different types of foundations to improve durability, resiliency, reduce labor time and cost potentially, and improve resistance to heat loss as well. So with that, I'm excited to announce our speaker, Lance, owner and inventor with the Easy Monoslab. Lance, during the downturn, was unable to retain labor. Skilled labor had left the construction industry to pursue money in the oil fields. This left labor needs to be filled by Lance, his wife Amber, and their 2 young children. Lance and his family went through the tedious process of traditional methods of forming, pouring, and insulating frost-protected shallow foundations. So they chose to come up with a new idea called the Monoslab Easy Form and put it into practice as a real business. It's a trademarked patent solution and is being sold in the U.S. and several states along with Canada, and it has certainly become his passion, his thrill to help move the industry forward. So with that, Lance, I will hand it off to you.
Good morning, Brett. Thanks for the opportunity to speak with this webinar. Like Brett said, kind of a crazy thing that this did become our passion, but the further we got in, the more we could see that there was a definite need to help contractors, homeowners, architects, engineers out with this particular phase of their project. So without any more, I'll get ready to bounce through this slideshow. If there's any questions, Brett, then go ahead and feel free to join in and let us know what you've got there. Okay, so frost protected shallow foundations. A lot of misconceptions about frost protected shallow foundations. So hopefully this slideshow will debunk some of those things. Quick history of frost protected shallow foundations. Frank Lloyd Wright built frost protected shallow foundations. He was very successful in the building technique. Early 90s through 1995, the U.S. Department of Housing and Urban Development constructed test houses. Some of those houses were in Vermont, Iowa, North Dakota, and a couple homes in Alaska. From the research from the U.S. Department of Urban Development, findings of frost protected shallow foundations, they performed very well. Their study found EPS can reduce winter heat bills by up to 10 to 20%, increasing energy efficiency for the end user. National Association of Home Builders also had a report. Frost protected shallow foundations could save up to 40% over traditional footer and construction. This goes back to my history, guys. I was in the home trades for 23 years. I was a general contractor, a concrete contractor, and I was looking for a way to form better and quicker, but also have the end user have a better product. So I started in on frost protected shallow foundations, forming, lining, doing all of those ways that you would traditionally think that was how we'd go about it. As Brett had mentioned, we lost a lot of our labor in the recession. We're a second home market just outside of Yellowstone Park, and so my market didn't really quit. The size of homes and cabins got smaller, but they wanted more efficiency. So we started pursuing this. I originally got into this because I wanted to help myself, help my forming. I never intended to market this material or this product, but found the need was real. So that's how we kind of came to you guys today. Here's a typical drawing of things that you're probably used to seeing in the field. The country, at least the United States, is used to that image on the right that's going to show a stem wall or a cinder block masonry unit that's going to extend that footing down below the frost line. The issues that I found with that is obviously a big excavation bill, a lot of expense in using that stem wall as my easiest way to transfer that footer down below the frost line. The other thing is the soils are a poor way to achieve frost protection and or R value in that structure. So image to the left, a typical frost protected shallow foundation. All we're doing with a frost protected shallow foundation is raising that frost line with a series of vertical and horizontal insulation. And the science behind it is great. I knew when I started into it that was going to be a good solid thing for me to do as a general contractor. That was still hard to form. You can see that lower wing installed on a tilt. I can tell you from the contractor's point of view, that's a very difficult thing to install because the machine doesn't excavate that tilt that way. That's where I started running into trouble. I could insulate the vertical piece very easily, lining my form, but the connective portion and that wing on the tilt was always very difficult for me to do. I felt like it was not clean work. I didn't feel like the seal was good. Not that foundation would have failed because of that, but I just felt like it wasn't my best work. I was also always wanting to do a little more than R10. Our air index here is 4,000, so I really was trying to do something even a little better. What determined insulation requirements? A lot of you are probably familiar with this, but in the United States and Canada, there's an air freezing index map and energy code. We base our product and our advice on the air freezing index map. We also have resources available that will tell you, just like NORAD will, town by town, county by county, of what your air freezing index is. This is kind of a lucky coincidence, if you will. When you look at the map that I'm going to pull up next, we're just outside the west side of Yellowstone Park. We're that little speck of dark blue that's going to pop up on that air freezing map. So our product was developed, tested, put through through the paces at a 4,000 air index, which would compare to Duluth, Minnesota kind of area. Shallow frost-protected foundations is an alternative to a deeper, more costly foundation. That's some of the things that I'd hit on with you guys. As a contractor, I always looked at this as, where's the value added for the customer? Is it making the home prettier, more energy efficient, easier to sell, less expensive for the end user? And the answer on a stem wall or a basement wall was always no to all of those things. International Residential Code, IRC 403.3, includes prescriptive methods for constructing frost-protected shallow foundations in heated and unheated spaces. This is probably one of the biggest misconceptions there is out there, at least in the building world. IRC code on 403.3, and then it goes on through a few other sections and subsections, is really poorly written. However, it does give you one option, which is ASCE 32, as far as a design. That is where I base my engineering from, because the design guide is a much better resource. It's much more prescriptive on what needs to happen for unheated spaces versus heated spaces. So that is what we're going to refer back to, even as we go on in the course, but as far as our engineering and other things are concerned. This is that air freezing index map. A lot of you are probably aware of this, familiar with it. Amount of insulation required to protect a foundation is a function of the air freezing index map. So I'm going to try to use my mouse here. This right here is where we are currently from. This is where the product was developed. So you can see there that we're a super cold spot in the Rockies. They're calling us a 4,000 air index. So we have actually tested our product for that 4,000 air index, and then we spread that all across the country, because aside from a little bit of North Dakota and Minnesota, everything is less than us. How to achieve frost protection. This is what we talked about lightly a moment ago. Two ways. The first way, which is super conventional, it's what the United States knows as how to protect, uplift, or frost heave in a building, which is through depth. I have so many people say there's only one way to do this. We've got to dig it below the frost line. The pure fact of the matter is when we start to hit places with expansive soils, North Dakota, a lot of Minnesota, their frost depth would go far, far deeper than 4 or 5 feet than a traditional stem wall covers. So I always try to tell people, we've got to go to a different method. We need to insulate rather than count on those soils, because the soil is such a poor insulator, especially when it goes into winter wet. So depth of foot or foundation wall, typically known as a frost wall, is set below the frost line, so people think, and then a foundation wall is placed on that to act merely as a transfer of load to the footer. So from the contractor, general contractor, concrete contractor, that stem wall is the most expensive way to transfer that load-bearing footer below the frost line. That's the fastest way to spend money on a job site, is literally in the dirt, in the ground. No value added for the customer. As a matter of fact, it's counterintuitive to the customer, because that stem wall typically is uninsulated. The insulation method, which is what we rely on. Insulation of the footing provides frost protection, limiting how much excavation depth is required. IRC code 403.3 specifies the insulation that are needed to achieve frost protection in a specific geographic region. That's that map that I just pulled up for you guys. Climate zones are noted in the air index map, and other related structures are susceptible to frost damage. This can be mitigated with the exterior foundation or slab with insulation to conserve the natural warmth under the structure. So although that air index map is going to be a driving force of what's required, typically energy code is going to be different than that IRC code. I'm seeing, and Brett can probably speak to this at the end, if we're doing hydronic heat or some other things, really R10 is the starting point. I'd much rather see R15, R20. We do have means to get people up into those bigger numbers. typically the slab edge is the comfort level of that slab. So when I see contractors want to cut down the insulation and expose concrete, they're really cutting away the comfort of that future homeowner in there, because they don't want to flash it and deal with that EPS or extruded at the top. In the United States and Canada, added energy codes may be required. That's what we just brushed on. Those are starting points when we talk about R10. Not that that's bad, but there is a little more room to go. What must be present for frost to occur? Kind of some misconceptions out there. Three things have to happen for frost to occur that's going to heave: moisture, freezing temperatures, and susceptible soils. By eliminating any one of those things, we can actually eliminate the possibility of frost heave. We do it through a few different means. We eliminate the moisture because we want to shed that water out away from that slab, not unlike that diagram that was shown to you in one of those first slides. That's the reason there's a tilt on that horizontal wing. We want to get that moisture out away from the slab. Freezing temperatures, that's where the EPS insulation comes into play. We want to eliminate those temperatures under and around that slab, out away from that slab, so that we can have no freezing temperatures. We're going to catch that Earth's natural temperature in the low 50s, and we're going to capitalize on that. Frost susceptible soils. Comes down to that thing again. If we're on expansive clay, that's okay. But what we need to do is keep that expansive clay, the gravel underneath that we've prepped for drainage, the drains, we want to keep that area stable and dry. So that's another reason we want to get that moisture as far away from the home as we can. Quick little study here from Kansas State. Soil alone is a poor insulator. 4 feet of saturated soil can be as little as R2, 1 inch of EPS, R3.6 to R4.85. I deal in Minnesota and North Dakota a lot because they have such expansive clay issues. So that's when I go back to that idea that when they dig a water line in a lot of places in North Dakota or Minnesota, and same thing here in eastern Idaho, if I'm crossing a driveway, my water line is going to be 8, 9, 10 feet deep if it's crossing a gravel driveway, because that frost is going to drive far deeper than 4 feet. So we insulate sewer lines, water lines, even beyond what's required by code to keep that frost from around them, even being that deep. Here's a quick example of some R values. This is a typical 4-foot wall. I think the slide's actually a little deeper than a 4 foot, but we'll go with that. 4-foot wall, 3.5 feet of dirt. R value 0.08 during warm, dry temps, wet, saturated, R2 in the total R values. So as far as protecting that foundation, yeah, it's probably going to get the job done. That footer's far enough below. The moisture's probably not getting there. There's definitely no value added for this customer on that, because that concrete's going to transfer that cold straight into their envelope. Here's some insulation methods, proper and improper. I see all of these out there. One thing that I talked about before is that slab edge. So many contractors want to cut that insulation down because it is kind of cumbersome to deal with, and they're not used to dealing with it. But when they leave that slab edge open at the top, it's definitely cold bridging in. Comfort level of that house is gone. I was always taught that it takes a foot for every R value into that interior space to regain the comfort level. So at that slab edge, if we're missing R10, it's going to take 10 feet inside that structure to regain that comfort level. And obviously that's going to calculate into heat bills, power bills, gas bills. We just don't want to do that. There's a lot of misconception out there, even in the building departments, about what needs to happen here. Heat loss and cold transfer occurs due to improper insulation. There's a lot of examples there. Problems with conventional insulation. First of all, I can tell you guys that none of these are my jobs, but I fought all these things out there all the time. You can start with that image on the left. The insulation has literally been put in 2-foot chunks, seams everywhere. Yeah, there's going to be moisture that penetrates all those seams. Do I believe that's going to fail as far as frost protection? Probably not. Is it a nice looking job to present to a homeowner that just paid $300,000 to $500,000 for the house? Definitely not. And they're missing out on some of their R value, and they are going to have some comfort level issues there. Middle photo there, this guy's trying to go about it right. Line his footer with some EPS, do all those things. But this is what I fought out there, which is, how do I form this? I want to give them a better product, but how do I deliver that to them? You go to the image on the right, that probably looks more typical of where I started 10 years ago. I would form, run that liner, make the concrete placement, and then I would have to remove those stakes, dig all of those soils away, and install that wing. As you can imagine, that's super labor intensive, and most contractors are going to follow the lowest hanging fruit idea. They're not going to dive in that far to make that perform that way. Another image that I've got here, this is a typical at least Western US trick. Utah, Idaho, Wyoming. This is a footer and a 4-foot wall. You can see that we're probably 2.5 feet above ground. This is in my air index, by the way. This is in a 4,000 air index. Their footer couldn't be more than 20 inches below the frost line there. Not to mention we're not insulated. The homeowner probably really doesn't know what they don't have there. If Idaho was inspecting and enforcing energy code, obviously that's a quick fail right there. Exterior insulation should really be on this project, even if they went with the crawl space. Additional areas of concern, I see these things happen all the time. Improper insulation methods. As you can see here, there's a lot of images going on wrong. This image is actually out of Billings, Montana. Flashing does not protect the insulation. Insulation does not come all the way to the framing member. There's cold bridging through this. No 6 inches of dirt to seal separation. There's just a lot of things going on wrong with this image here. Light inspection, so they're not picked up on it. Insulation methods for frost protected shallow foundations. This is an image of what we produce, monoslab easy form. This allows you to form, insulate, and backfill before the actual concrete is placed. You can see we have a slope design to shed the water away. Instead of the minimal of R10, which we talked about, median R values, we get clear into the R50s. ICF stacks on this very nicely and can be done in the first pour. Just a few points there of why this is such a great setup. So here's how we're dealing with a heated space scenario. So obviously we've got our form, our insulation on the exterior of this. This is what they would call IRC 403.3. It's not required to have subslab insulation inside the home. I'm not finding that very typical, and I definitely wouldn't recommend that, but it will pass code. I don't know if it passes energy code or not. I doubt it, but it will pass code. So you can see that you've got a vertical and a horizontal insulation there through the form. Allows backfill before it's poured, and that you can actually see that an amended piece on there actually lets a contractor, architect, engineer get that project to R15 at the slab edge. As you can see underneath, infill, 100% compactable, non-frost susceptible gravel or sand. Guys, I always recommended straight rock. Straight rock in my world is easy to deal with. I know that it's not going to be frost susceptible. It's maybe a little tiny bit more money, but it's the 100% method, in my opinion, to actually make that perform. Here's where there's probably the most misconception in the business, inspection offices, contractors, anybody else, which is unheated space. Unheated space is definitely allowed. I have engineering in at least 25 to 30 states that is state specific to literally implement unheated spaces. And all that's really going to tell us on an unheated space is we have got to have a full thermal break from the earth under that unheated space. And in certain instances, there might be an additional wing required beyond our monoslab form. Basically, what we're trying to do in that unheated space is disconnect any contact with the concrete and the earth itself, and we're trying to hold on to that natural geothermal longer through the year. So, for example, if we go to Duluth, Minnesota, we're going to have to put an additional wing on top of our 24 by 24 inch form because we need that frost-free days. We need to hold on to that geothermal heat longer, push it out from underneath the slab more days out of the year than you would in Des Moines or Grand Rapids or other places. That's where that air index comes into play, is determining, hey, how many days do we have that are below freezing and how much more insulation do we need? We sell product clear up into Canada, and we could talk about that later, but we deal with air indexes far colder than even Duluth. So that's kind of what we're showing here. Obviously, we have the frost or the 100% compactable gravel or sand. You can see there's two details there. You can put that subslab insulation down at the bottom layer and then fill over it, or you can install an interior form, thermal break the footer, and get your thermal break that way. I think both of those are right to me. I don't think there's a problem with either one, but it's definitely an important thing to do to make sure that that is continuous underneath. I'm not seeing anything more than R10 underneath those cold spaces. By the way, that would apply if we're going to do a stoop, a porch, anything that's not going to be heated. That is going to dictate that. That's where this ASCE 32 design guide comes into play. It'll actually give you the formula to calculate, hey, I'm in Des Moines and my median air temperature is this, my air freezing index is this, and here's my calculation. I do have sample engineering available for those states. I do list out a state by or a city by city in each of those states and give an example so that it walks people through that process of determining what's the right amount of insulation. Here's an image of a project that was set up, first time use guy. Notice the slope of the insulation, the slope of the form. That is going to do the first thing of what's needed to eliminate frost. So we're going to eliminate the moisture. We're going to get that moisture as far away from that slab as we can. Part two is we're going to talk about insulation. R10 is a minimum, but we're going to go much bigger. By default, a contractor cannot mess up the required R value for energy code or IRC code. Susceptible soils, it goes back to keeping that moisture and those temperatures away from that project. Here's where I come at this product for everybody that's listening. And here's where I got to this point. If I put a product in front of a concrete contractor that he can't install or it takes him too much time to do, no matter what we put on paper, he's uninterested in installing it. So what we've got here, and this is where I was kind of came from a unique space, is the general contractor and the concrete contractor. There's something in there for everybody. We want to make sure that the general contractor feels like his liabilities are covered. We've done it far above and beyond code, whether it's IRC, IBC, energy code. There's something in it for the concrete contractor. I want to deliver something to them that they're happy to install. They're installing a green product, even if they don't know that they are, that's taking less time, less money. We're eliminating 2 concrete pumps on site. We're eliminating 3 trips to do 1 job. So we're eliminating any of those vehicles, anything on fossil fuels that's headed out to that job back and forth day after day. And third, maybe most importantly, that a lot of people lose sight of in the business is we're delivering an end product. We're delivering a frost protected shallow foundation that, if done correctly, is cheaper to heat, cheaper to maintain. It was less intrusive and expensive to get to that point. The end user is the one that wins over the next 100 years, whether that's 2 homeowners or 10 homeowners. They're all going to win with those less expensive energy bills. Here's a couple of things that I see out in the field that I kind of like to discuss. The image on the left is a stem wall. So when we go about constructing that stem wall, and that's what I'd done 10, 12, 14 years ago, we're going to construct the typical spread footer. That's one pour. Then we're going to go strip that. We're going to install forms for a stem wall. That's another pour. We're going to let that cure for 10 days at least. We're going to backfill. Then we're going to pour a floor in that if we're doing a floating slab or a garage floor. So in my neck of the woods, that's 3 concrete pumps. Right out of the get-go, we're going to spend $3,000 in pumping concrete, really no matter what the size of the structure is. There's no value added for the end user or the concrete contractor. The concrete contractor's been back there a lot of trips to perform that work. End user just gets skunked out of the deal. There's no insulation to that. With a monoslab form, everybody's in and out one trip, one pump. End user has R50 around their structure. They can win the day. We come to this center detail, trench footer, wall, floor. So I see this a lot of times too. I get down into the Midwest. We're going to dig a trench that's 30 inches deep. It's spec'd out as 16 inches wide, but you can even see there, by the time we excavate that, we're going to be blowing more like 20 or 24 inches of concrete in there. Once again, we're back to that void fill. Concrete is the most expensive void fill. The other challenge with that photo is, how do I insulate this? If you put a piece of insulation against the outside edge of that trench, that's not going to look good. The next part of that project that's going to happen is once that trench is poured out, we're going to form a slab up on top of that. So how do we connect the insulation from the slab to that trench style foundation wall? It seems like easy, low-hanging fruit for the contractor to do this method. I don't have to form anything up besides a 12-inch slab on top. But he's paying dearly in resources that could be used in better places because he's filling that huge trench with concrete. Completely unnecessary, hard, if not impossible to insulate. We're definitely not going to get a thermal break underneath the floor connected to the slab. So there's definitely a lot of issues going on there. When I come to this image on the right, slab on grade with slough out to void fill. Once again, there's a lot of things in this image that I really, really hate. I hope they remove that vegetation from inside. They've formed up. They're going to void fill with concrete there. No insulation. There's just a lot of things going on there. Contractor spends a lot of time, labor, money to form that. A lot of that form work is simply going to end up in the landfill. That's definitely counterintuitive to what we're trying to do. I used to form with lumber lined with insulation. I had 2 trailers backed up to the job. One was a dump trailer, one was a form trailer. And believe me, it's half and half when you strip these jobs off. Those forms only last for a few jobs, and all of a sudden you're filling up the landfill with lumber. Labor savings. This is when we get back, down to the general contractors, concrete contractors, minimal excavation. Our product is actually installs with no kickers or less kickers, less stakes, no return trips to tear down, less pump trucks, which we kind of touched on there. Those pump trucks kind of, if you guys can't tell, those kind of hit me in the gut, because when I pay pump truck bills on a project, a residential project, and all of a sudden I've had 3 to 5 pump trucks, I've spent $5,000. That's insulation I could have put in for that homeowner. It's better cabinets, it's better flooring, it's better water heaters. There's a million things I can do that are value added to that end user, and they never ask how many pump trucks it took, or were excited that it took 5 pump trucks. Fewer days on site for you guys that are on the webinar right now, and you're running in the North Country like we do. 120-day, 150-day building season is pretty typical. Days matter to us. I want it done right. I want it done efficiently, but I also want it done now because I don't have time. I'm going to start in the mud in the spring, and I'm going to finish that house in the mud before it snows big in the fall. So days matter a lot. Less labor required on setup. One thing that's universal, when we go across the US, Canada, everywhere we go, the shortage on labor is deep. I don't know whether there's any quick resolution to that besides we've got to implement products and ideas that make the houses faster and better. I fight the labor part really hard here in Island Park because we're a vacation town. Homes are expensive. We actually don't have one apartment building in town. So my labor is non-existent at best. So ideas and products that make labor run faster is probably the future. Money savings, forming time decreased, less pump trucks, decreased concrete yardage. Go back to that point of void fill. Concrete should never be a void fill item, yet that's a pretty common idea. Concrete's expensive, not value added. We obviously want the right amount for structural needs, but a bit more than that is going to be a waste. Return trips, strip and clean forms. I can tell you we've got a lot of guys on the road adding to what's going back and forth, because return trips for guys mean burritos, cigarettes, coffee, hot chocolate, talk on the phone with their girlfriend in between. This is actually killing the concrete and general contractor. Once again, no value add here. Value is added with monoslab easy form by providing insulation required by IRC, IBC, IEC. So we're trying to actually give them something for less money. Another big question that I face all the time, and full disclosure, I was not a commercial contractor. At least half of the forms that come out of our business are for commercial buildings, Dollar Generals, Arctic Circles, small strip malls, airplane facilities, airplane hangars, breweries, Coca-Cola dealer or Coca-Cola distribution facilities. So there's a lot of different mix of where those products are going. I sell as much to concrete contractors at the will of general contractors. We're starting to be spec'd. We've been in this for 3.5 years now, so starting to see a lot more spec, John Deere dealerships, things like that. Monoslab provides a far superior process compared to traditional forming, yet it's simple, easy to use. Quick thing to brush on there. We actually sell to Habitat for Humanities. We did their conference week before last in Atlanta. We can actually sell to a local affiliate, Habitat for Humanity, and they can set up a monoslab foundation with volunteer labor in a few hours. What that's allowing a Habitat affiliate to do is have a far better product than they're just paying a concrete contractor to come in and place concrete and power trowel it off. They've eliminated all that extra labor in there. So we're pretty proud of the fact that we sell to Habitat for Humanity spread out across the U.S. and they're doing it with volunteer labor, which is neat for them. They've never been able to snag volunteer labor on any type of foundation work. When to use. Monoslab can be used in place of traditional footer, 2-foot, 4-foot stem wall, floating slab. Big misconception. I'll always talk to somebody and they'll say, I know a guy that does slabs, and it's like, that's great. Now let's talk to the guy that's wasting all of his time and money doing spread footers and stem walls on 2-story or under buildings. We can save those guys a lot of money. We can do a whole lot better energy on that project. It'll be faster. Everybody's going to win in this process. So really, it's a replacement for anything. Duluth is actually on a 5-foot stem wall. We sell a lot of product in Duluth, so we are applicable into those deeper frost areas. Obviously, it can be used for a slab on grade construction, fast forming, daylight basements. So even if you're going with an ICF, you can install that on the daylight portion of that basement. A place that comes to mind is Bismarck. A lot of daylight basements in Bismarck, and so that's a good application there as well. Not a major part of what we do, but it is a great application. Quick reference over here, this photo you see on the left, this is a first time use out of Saratoga, Wyoming. This contractor never had done a frost protected shallow foundation. First time use, all in, he's got that project done, looking good. One day with 2 guys. So what we've done is we've taken a Wyoming contractor that typically isn't called on code or energy code, and we've brought him all the way up to speed. All of a sudden, he's going to have a full thermal break in this custom home in Saratoga, which he's never been able to offer before, and frankly didn't know how to offer it. So first time use here for this gentleman. Did a killer job. He's got a drone picture there. I use the image because he is brand new to the world of let's thermally break it and insulate it very well. He told me on that project, with not going with bigger equipment, bigger dig, all those other methods, that he saved almost $25,000 on that project. Some examples of where we're applicable: steel buildings, commercial buildings, apartment buildings. I may reference, unless we do a spread footer underneath, apartment buildings are limited to 2 stories. I do have a code compliant method to change that from a turn down to a spread underneath, but that is one little point that you need to be aware of. 2 stories is the limitations on turn down style footers typically. Like I said, I do have a engineering amendment to that does a spread footer. But condos, residential buildings, retirement homes, garages, shops, we send out an awful lot of product to onesie twosies guys that are doing cottages up on the lake, shops, garages. That's kind of the internet side of the business, but all of those items are applicable on there. Just in conclusion, got some images here that were actually done using our product. You're going to see that, like a commercial building, like a Dollar General, they're not going to go all in. They're not going to do sub-slab insulation. They are going to do perimeter insulation to protect against frost. Dollar General and some of those places have not come, full circle there with that. John Deere dealerships, we've done a couple of those. We are seeing sub-slab insulation there. That's kind of nice to see. Mechanics rolling around on the floor, a lot more comfort during the day. Retirement housing, this is actually a home up here on the right. That's actually one of my constructions. That's got a fully insulated, frost protected shallow foundation underneath it. I don't know, I think it was 1,800 square foot home. Minnesota State Roads building. EEC buildings out of Montana. They're a design build firm, in-house engineering. And then I show that image down there on the lower right. Not that it's the most beautiful image, but the reason I show that image is they're shooting rock in there. And Scott Craven, Habitat for Humanity, he was a local affiliate. That's his first time set up. He set up that foundation with a half a dozen boys, high school boys, after their baseball practice on a weeknight. So they're shooting that gravel in. He's going to run his sub-slab insulation. They're going to have a full thermally broke house done with volunteer labor for a Habitat for Humanity. So out of all those images, there's more beautiful images, but I might be just as proud of that one as any of them, because they did that with volunteer labor and produced a better end use product. With that, that's the end of my slides. I'm sure we've got some time for some questions if there's some, maybe from Brett or anybody else out there.
Yeah, so we definitely do have some questions here pouring in, and before we get to those questions, let me just real quick and make sure everybody knows where to get their CEUs. So just real quick, for those of you who want to pick up your continuing education credits, just make sure to take that survey that will pop up at the end of the session. And those of you listening on demand in the future for the recording, make sure to take the quiz with an 80% passing rate. GHI members and YouTube users, go to YouTube. USGBC viewers, follow the USGBC instructions. And just real quick, if you're up on YouTube or on our website, just go in, click that YouTube link there down at the bottom, then follow that down to the details of the recording. Click show more, and then from there follow that down to the link to grab the quiz, and then follow the quiz submission instructions. And then as the questions are pouring in, real quick, a huge thanks to all of our members, our board of directors, our volunteers, everyone who lets us do what we do. And a huge thanks to our top tier sponsors, Shrinergy, for on the go or in your office or house, battery backed up solar powered for not if, but when the grid fails. Mitsubishi All Electric, helping you get to net zero in single family renovations up to commercial-based multifamily and commercial use structures for air source heat pumps that work when it's very cold. And then T-Stud, structurally insulated framing systems that save money behind the walls. So yeah, let's get into some of those questions that we have here, and we do have a lot coming up. I think the first one we had was very relevant to renovations, and let me just pull that open here.
Okay.
So how do you apply this approach to a historic district or design that calls for a 2+ block courses exposed above the grade? What are the options for keeping costs down?
Okay, so not exactly my area of expertise, but I can tell you how we come up off from that frost protected shallow foundation. Ours has a perfect platform for an ICF, or obviously they could do a small curb or stem wall up off from that. As far as the historic part of that goes, I could not speak to that at all. I do have a lot of guys that will either form that curb down or form that curb up because they want that small curb exposure. I'm not sure what the facade is on that historic district. With an image or a drawing, I would think I could probably get something figured out as far as how I would attack that.
Okay. What material do you use to protect the exterior insulation that is exposed above grade?
Okay, so I have a couple of different options, and I can tell you what I use for starters. I always went with a metal cladding. I've got super extreme weather here, so I always preferred to go with the metal cladding. I could have them build that into a step flashing. Depends on if I was going with the R15 or the R10 at the edge. If I was cantilevering a traditional 2x6 over the plate or ICF. I also list a couple of different products by brand in my engineering. A foam coat style product that goes on there that can be like a stucco finish that goes on there. I always fail to say a specific product. I do have 3 or 4 available on the website through engineering because geographically where you're at in the country, it may be called something and you may have something different available to you. But my preference was a metal flashing that was either going to tie into a concrete color or a soffit fascia window grid color so that I could match that look of that property.
And I think you pretty much answered the radiant heat. I didn't know if you wanted to. There was a question about how well it works. I don't know if you wanted to add any more to that.
Yeah, I wouldn't mind. I can tell you, I built many homes for lots of people. I've lived in 21 homes myself over the course of 24 years. My wife just loves that, by the way. My last home that I set up obviously as a frost protected shallow. I actually did an EPS infill that corresponded with my 18x30 form. I actually did an 11-inch thick EPS infill with hydronic heat over the top of that. So I'm definitely all in on what's happening down in that slab. Like I said, we're super cold. I can tell you that my boilers at best run very lightly because the thinnest point is underneath my footers, which is R20, and then I go clear up into the R50s underneath my slab. So as far as the creme de la creme, if you will, of the ways to do a foundation, and you're going to run hydronic heat, super great option. I'm sure there's corresponding products in your area that will actually accept the hydronic heat in a snap style environment. I know that Logix has one. I know that I don't know that Nudura does now. A lot of different manufacturers will have a product as far as subslab that will accept that PEX pipe in there also. So yeah, I'm all in there. I actually did my 1830s. I put a 12-inch extension on it because when I've insulated, probably a great point there. When you insulate that much underneath, everything needs to be treated as unheated because I'm not going to have any heat loss, or at least I shouldn't have any heat loss from my envelope inside going down to assist keeping that ground thawed. So if you're going to go super insulated under that slab, consider it as unheated and employ the unheated specs as far as ASCE 32 design guide is concerned.
Great. Can this be used for like a passive house, rated slab, 6 to 8 inch EPS all around, and perimeter thickened slab? This seems more like an unheated slab, and it won't keep the ground thawed.
Yeah, it's you can actually use it for both. Like I said, if you go into ASC 32 design guide, it will tell you heated versus unheated. We can definitely go both directions on this, and we do. There's I don't know, 30% of the buildings that we are in contact with that we deal with are unheated space. The rest of them are heated. I do get a question all the time from building officials, building inspectors that say, well, if you put sub slab insulation down, then it's going to freeze because we haven't let that natural geothermal do its work. And that's, like I said, we refer back to the design guide. We literally install sometimes a little bit bigger wing on there to keep that frost line out of there. So it's for both, just has a little different application, not a lot different though. If you refer to the design guide, that's a great resource. It'll show you with really good detail on which one is applicable for what you're doing based on air index and median temperatures.
So the next question is, what are some good ways to protect the corner where the framing starts and the slab insulation ends?
Okay, so if I'm going to set up a traditional framed house on top of a monoslab easy form job, I'm going to want to cantilever my treated plate if the inspector allows. I'm going to want to cantilever my 2 inches over that plate. Then that sheeting will come out almost flush with the edge of that R10. And then that flashing can run straight down, which I like a whole lot better than R10. Certain municipalities, the inspector will get an issue with cantilevering that plate. I generally try to walk them off that ledge because more times than not, that structure is only in that 3.5 inches of a typical stud, not the 5.5 that they're using in that area. It's insulation void fill. So if I have my way, I like to see that plate cantilevered and the flashing runs straight down. If not, they'll have a step flashing that's going to come down over that. Just as a little side note, when you're looking at a monoslab easy form, there's a triangular portion out there beyond where the 2x8 whaler would go. That portion is breakaway. That portion is for forming purposes only. That keeps that friction fit on that 2x8 in place. So I'll get a lot of questions about how do I get my dirt to seal separation. That small portion right there is a breakaway. So that will give you your 6 inches of dirt to seal separation and allow you to cantilever that plate over, or it will accept an ICF that goes straight up on top of there. The 2x8 is a 2x12 instead, and you can actually fasten that all together at one time to make one pour to do your slab and the first run of an ICF.
Great, thanks. On slide 22, should a drain tile pipe be installed outside of the insulation and slope to one end of the foundation to take water away?
That's a super great question. Minnesota, I'm definitely seeing it happen that way. North Dakota, they're super in and real on their drain tiles because of those expansive clays. So yeah, out there at the toe of that form, right out there at the edge, that would be the appropriate place for that drain tile to go. I believe Minnesota, if they're in the city, they're actually going to run that out to the curb. Depends on how they're dealing with it from there, but yeah, that's the appropriate place for it. And if you're in those expansive clays, that's a super great idea. We want to keep that dry.
Is there a filler of foam you put in the 2x4 bracing slot?
Yeah, so when that product is shipped out, once the 2x8's been removed, we actually send the blank to go back in there. So that'll allow you to get to that R15 scenario if you're wanting to do hydronic heat. I know Energy Code requires that a lot of places. So we do send that inner filler back out there. To me, it's a no-brainer. Why not put it in? It's going to give them extra R5, but yet you'd be surprised how many guys don't put it back in. So you can see in that image that you're looking at, is it slide 22? Yes. You can actually see if you look close, there's kind of a score line there. That's the portion that breaks off, and then that extra R5 literally will adhere to the R10 that's already adhered to the concrete slab. So super great question.
Do you dig in and install water and sewer laterals before setting the forms?
I've done it both ways, and I see guys do it both ways. I can tell you, and we can use that image number 22 just as an example. Looks like he's got some stuff stubbed up in the back. If I didn't have those placed within the slab, what I would do is leave one form or a form and a half out in the front so that that excavator could get in there to place those utilities. Often on a project like this, his infill looks good. He's already got it built up, or it's got his virgin in there. But there's been a lot of instances, if you take some of those bigger images like a Dollar General store, they'll actually leave a couple forms out so that they can back a side dump or a belly dump back into that slab and place material that way. So myself, I've actually left forms out to creep a truck in there, a mixer in there if I don't want to use a pump, and then I'll quickly form that opening and close it up as he's leaving with that last truck right there. So it can be done either way.
So there's no need for the insulation to extend the 40 to 80 inches outside of the footing at the corners per the building code?
It depends on your air index. So there's kind of a line if you're coming across. A good example would be in North Dakota, Minnesota. When you bring that I-90 line across, I believe it's I-90, you go north of there, and there will be add-on additional requirements that make those corners or extensions necessary if it's unheated. When you get into air indexes like like most of the country, if you get into one of our bigger forms, an 18 by 30 or a 24 by 24, you're actually going to see that those are not applicable because we've got so much insulation beyond requirement, and even as far as the width and height of that. So the answer is yes and no. You know, if you're talking about the UP, northern Minnesota, I mean, a lot of Minnesota, the upper part of North Dakota, the upper part of Montana, yeah, sometimes those corners are applicable. But that's one thing that my engineering that's based on ASCE 32 will spell out for you in a simplified chart version. Anybody that's on, more than welcome to reach out to me. I've got engineering, and there's some great sample projects in there that will kind of get you familiar with what needs it and what doesn't need it. I know when you get down into Indiana or Ohio or some of those other areas, you know, if you're using one of our bigger forms, you can negate the corner insulation because of the way the engineering works out and the R value that we provide. So the answer is yes and no.
What depth of excavation is required? Are there differing heights of forms available? Are they specific to that air freezing index?
Great question. We do have 3 different sizes of forms available, and they are relative to that air freezing index. So I have a standard form that's 16 inch by 16 inch. That provides 32 inches of frost protection by code. Then I have 2 larger forms. I have an 18 by 30, which provides 48 inches of frost protection, and a 24 inch by 24 inch. I can tell you on those, I can tell you kind of how those go. The 24 inch by 24 inch happens a lot on a commercial building, a Dollar General building, because they're going to be a steel frame structure, a light structure. Uplift on that building, they're going to want that bigger club footer, the deeper club footer to go to a 24. 18 by 30s are pretty typical in the North Country as far as residential and some commercial. 16 inch by 16 inch forms are going to kind of be the bread belt of the United States, if you will. They're going to make code all across Indiana, Iowa, Kentucky, any of those places, you know, kind of from that Iowa, Minnesota line down. So 3 different sizes. Also, just as a little side note, if you take that 2 by 8, even on a 24 by 24, and replace it instead of the 2 by 8 and go to a 2 by 12, that'll give you 4 more inches that you can put a piece of insulation there to extend it, so you can actually get to a 28 high and a 24 wide, and then obviously that wing can extend as much or as little as required by code or that you're comfortable with.
How about resiliency? So, this particular question is resiliency to earthquakes, but I guess I could imagine flooding and any other natural disaster that might damage foundation. How does it protect against these?
Sure. So as far as the EPS itself, the reason the EPS is great in this situation is the reason that it's horrible if we're going to make a cup or a plate. The longevity of that EPS buried in the ground will surpass many, many generations. EPS by volume will absorb right close to 4% by volume. It will still retain the R value. So let's hypothetically say it gets super moist season after season. EPS will actually release that moisture better than an extruded would per se. Like I said, it absorbs some moisture, but it will release it. It's better at releasing it. As far as the design of the home, most of the typical things you're going to see in a stem wall are going to be in that slab. You're still going to have your Simpson HD straps. You're still going to have your regular anchor bolting. You're still going to have your regular things there. As far as putting that slab over less than desired soils, because that slab has got a spread out footprint with the Turndown, it's actually, in my opinion, going to perform better than a 16-inch spread footer that's sitting on marginal soils. Obviously, we're gonna use that benchmark of 1500 psi for virgin soil as kind of a starting point, but that monolithic slab should perform super well over the top of that. As far as the flooding issue, I tell guys you want to make sure you keep your 6 inches of dirt to sill separation. That's important no matter what kind of home you're building. Make sure they keep those. Obviously, if we're into a commercial building, that's not going to necessarily be applicable because they're going to ramp up into that door with no step. But as far as how that performs, I think if you take that monoslab form and build it in the traditional ways you would your foundation, it's going to perform very well.
So you spoke to this a little bit, but what about alternative insulations? There is a sort of a foam-free movement underway, and for slabs, we've seen foam glass, which isn't foam, and like a rock wool pop up. Like, what are your thoughts on being able to use that with this system?
I am completely unfamiliar with those two products you just mentioned. I wouldn't know enough about them to speak intelligently about them, put it that way.
Okay.
I know as far as the EPS is concerned, like I said, the reason it's good for us is the reason it's bad in the landfills when we send a to-go container in it.
Sure enough. How does the underslab insulation transition into perimeter form work?
Okay, so quick example of what I like to do when I'm setting one up. Let's go back and we'll just use that image 22 that's still pulled. That's a great one to teach off from. So if I was setting this up, I'd have it just like this gentleman does here. I would lightly backfill around that. That eliminates all the kickers. From that point, let's hypothetically say I've got a 16-inch wide footer. I'm going to rip some sheet goods down of my desired depth and PSI. I'm going to rip those down to 16 inches, and then I've got an interior form that can butt up against that. Gravel infill comes into that, and then the whole thing is capped with more subslab insulation. What that'll do is keep a full thermal break. It'll keep it tight, and none of that formwork inside needs to be staked. I don't want a wood stake inside there for potential rot. I don't want to leave a steel stake in there, obviously. So steps 1, 2, and 3 is exterior, backfill, exterior, sub-slab insulation under the footer, slide the interior form up next to that if that's something that's being employed, backfill that to the top, and then go ahead and cap it with your sub-slab insulation. Like I said, I did mine a little different. I bought some 4x8 sheets that were 11 and 13 inches. So what I did was exterior, sub-slab underneath the footer, and then I would slide those, a geofoam block basically up next to that. And I had a completely gravelless system under there, which in my neck of the woods is about a wash on cost because my gravel's super expensive. So once again, gravel, no extra value added for the end user, which happens to be me in this case.
Is the insulation treated for termites, carpenter ants, and locations where they exist?
It is. We actually, in locations where we're going to have those issues, we actually borate treat.
Okay. Are corner treatments laid loose or attached to each other?
They're attached to each other. So that corner you're seeing right there, so that project you're looking at, this is the beauty of that. That gentleman has one screw in each corner. So that whole structure is held together with 4 screws. One thing you're not seeing there, he's bypassed his corner, which is, he's done that correctly. Right down here, he has bypassed that corner because that corner is a super pertinent part of the insulation. One thing that we can do is we can prefabricate corners from manufacturing, so they have that mitered exterior or an inside cut, bay windows. There are things that we can do that make it even a little more DIY friendly. But generally, and I can't tell what size of form this guy's using, it looks like maybe they're 2 foot by 2 foot. Generally, if that's the case, you're going to start that first form 2 feet past your first stake, so that when you come back around to it, we have full protection into that corner, and then fasten that 2x8 with a Torx screw or a Phillips screw to hold that together.
Have you any experience with the use of extended plate and beam type of wall construction built on the slab? Seems like this should eliminate the need for flashing over the top edge of foam.
I have not had any experience with it, but keep in mind, at the point that we're at in the business now, even this image sent to me, I believe this is from Wisconsin, it's rare that I actually see what they've done to implement different ideas beyond the slab. Generally, the guys that are going to buy slab work are educated guys. They've been online. They've talked to gentlemen like Brett that's running this. And so they implement things that are probably outside of the everyday norm of the building world. I would think that's probably been done. Do I have an image of that being done? I don't. So I generally don't. I'm getting to the point where I don't get to see near as much of the end use or the photos as I'd like.
Mm-hmm. What would you typically insulate the pipe penetrations to going through the insulated slabs? Do you step up the insulation valve at the penetrations?
I handle those pipe penetrations like I would if I was doing a basement floor or anything. Generally, I'll run 3 to 4 rows of seal from top to bottom around those, just to give that a little extra padding, a little extra insulation. I do that as much in case there's a problem and one of those pipes is broke off and we have to slip a bell end over it or anything. I haven't typically beefed up around those pipes, like I said, other than 3 or 4 wraps of seal and duct tape around those.
Mm-hmm.
Onto that, kind of an extra answer onto that too, though. I will tell you, if I was installing this slab right here, I would keep 1 can of expandable foam or 2. If I had any of my corner cuts or gaps or anything that I didn't like or that had a little gap in them, I would definitely seal them up. A can of foam is $6-7. To me, that's well worth it to tighten it up.
Okay. This system appears to be ideal for pairing with 3D panel wall construction, where the welded wire panels with embedded 4-inch rigid foam get built in a day, then shotcrete applied to both sides for the structural sandwich. Have you been involved with anything like this?
We're right on the. It's a great question. We're right on the front end of a gentleman out of Morgan, Utah. I think it's called. Is it Blackburn? It's exactly what he's doing. We're right on the front end. Going to do a couple of buildings with him. New to me. I'm not familiar with the construction other than what I've talked when I've met him down there in Morgan a couple times. But yeah, that's something that's in the near future. I would suspect we'd have our first project done by early summer with him.
All right. Well, Lance, those are all the questions I see.
Okay.
So I think we're a little over our time here, so we're just gonna go ahead and wrap up. But before we do, where can people go to learn more, contact you, or if they wanted to get started in their state, is there anyone local they need to contact, or can you just give more information?
Yeah, the best point of contact, you can go to monoslabeasyform.com. That'll get you to our website. There's outside sales. My information's on there. Amber's information is on there as well. I do have a lot of resources. There is some setup videos, YouTube videos. I do have downloadable information for engineering, ICC listings. But at least at the starting point, if you're just on the front end of implementing those ideas, certainly give me a call and shoot us an email. I'm glad to start with you at least on the front end of your projects until you get more familiar with spec, ASCE 32, all of those different design criteria. I'm more than happy to help.
Great. Well, Lance, I really appreciate your time today. Thanks to everyone for attending. Have a great rest of your week, everyone. Take care.
We appreciate you. Thank you.